Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic center of gravity of unsymmetrical section. Let's go to the numerical. A uniform lamina shown in figure consists of a rectangle, a circle and a triangle. Determine the center of gravity of the lamina. All the dimensions are given in mm. Okay. So here a lamina is given. It consists of a rectangle, a semicircle, and a triangle also. Okay. So for our convenient, the given lamina will be separated into three segments, such as rectangle, semicircle, and a triangle. Okay. And then, guys, the reference video, an overview of center of gravity. In that, the X bar, Y bar formulas of the different shapes, including a rectangle, triangle, semicircle, that and all clearly explained. So, for reference, you just to watch that video. That video link is given in the description box of this video. Okay. And then that one more video, that is center of gravity by moment method. In that video, we described the derivation of the formulas X bar, Y bar, even Z bar also for the areas such as the lamina, then volume, and then even mass also. Okay. So for reference, go to the description box of this video. The video links an overview of center of gravity and one more video, that is center of gravity by moment method. Both the video links are provided in the description box. For better understanding this numerical, you just to watch that reference videos. Okay. Here, first thing, we have to consider the reference axis. Here you can see this is not symmetry about any axis with respect to x axis or y axis. It's not symmetry. So we have to calculate both x bar and also y bar. So we have to take the reference axis for the calculation of x bar and y bar. Here we know that the reference axis, that means for y bar calculation, we will take the bottommost line of the diagram. Here you can see this is the bottommost line. So I have taken that bottommost line as the reference for y bar calculation. Same for x bar calculation, we have to take the leftmost line or the point. Here you can see this semicircle edge or the top point of the semicircle. That will be the leftmost line. So we have to choose that one as the reference line. Do you understand? The leftmost line of the semicircle. Okay. That will be the reference for x bar. Okay. So now I just write the formulas of x bar and y bar for our reference. And then the segments. First, I'm going to take the rectangular portion as 1. Okay. And then the semicircular portion as the second one. This one, that is the third one. That is the triangle. Okay. So here, there are 3 areas. Okay. Segmented areas are there. So we can take the x bar formulas. And then here it is a lamina. So we have to consider the areas of the laminas. So A1 x1 plus A2 x2 plus A3 x3 divided by A1 plus A2 plus A3. Same way, the y bar, that is A1 y1 plus a2y2 plus a3y3, the whole divided by a1 plus a2 plus a3. So to calculate x bar and y bar, we need to calculate a1, a2, a3. That means the areas of the three different laminas. Then x1, x2, x3, the distance of the center of gravity of the particular areas from the reference axis. Okay. For x bar calculations, this will be the reference axis for x bar calculation. And the bottommost line, that will be the reference axis for y bar calculations. Okay. So for y bar, same way we have to calculate y1, y2, y3. That means from the bottommost line, the center of gravity of the particular areas. That means from bottommost line, center of gravity of the rectangle, that distance, that will be y1. From the bottommost line, center of gravity of the semicircle, that will be 2, y2. Same way, y3. Like that, we have to calculate. Okay. So first, we are going to analyze these data. That means a1, x1, y1 for the rectangular portion. Okay. So first one for the rectangle, I'm going to take that as 1. Here, first we have to calculate area of the rectangle, that is A1. Here you can see the value of A1. That means the length multiplied with breadth. Okay, L into B or B into H. That means if you had taken the linear dimension as B and the vertical dimension is H, then that will be B multiplied with H, whatever. Here you can see this rectangle has the linear dimension on the x-axis, that is 100, and the vertical dimension on y-axis, that is 50. So it will be multiplication of 100 multiplied with 50. That means we can write 5000 mm square. Okay. Then x1. For x1, already we had discussed the reference axis, that will be the leftmost line. Guys, you can see this in reference video also in an overview of center of gravity. And for a rectangle, here we are going to discuss the linear dimension. For possibly the center of gravity will be here. Okay, that means this will be the CG of 1. That is B by 2 the distance, H by 2 the distance. Here, if the value B in the linear dimension in the x-axis, if that is 100, from here, okay, from here, this distance will be 50. Okay, that means because from here only the rectangle started, so it will be 100 by 2. Okay, but that is from the edge or the overlap of semicircle and rectangle. From that point, the distance of center of gravity is 50. But we need to calculate the CG1 from the reference axis, the leftmost line. From the leftmost line up to this edge, the overlap between semicircle and rectangle, that is 25. And from the overlap to the CG1, that is 50. So we can write 25 plus that 50, or otherwise we know that 100 by 2, that is 50. Okay. So it will be 50. So 50 plus 25, that is 75 mm. Then y1. In vertical distance from the reference axis for y bar calculation, that is the bottommost line. Here you can see the rectangle, the bottom line of the rectangle lies on the reference axis. So from here, this will be h by 2, that is 50 by 2. So that is 25 mm. Okay. Then the second one, semicircle. Okay. Second one, semicircle. That is that 0.2. Here in semicircle, same way, A2, it has only 180-degree angle or overlap, whatever, in a circle. So we will get pi by 2 r square. Okay, this things also we have discussed in the an overview of center of gravity. So in that you can check how to calculate the area of semicircle, even quadrants also. Okay, or any circular sector. That things and all we had discussed there. So for reference, you just watch that video which is given in the, that means the link is given in the description box of this video. So here A2 equal to pi by 2 multiplied with r square. Here you can see this 25. That will be the radius of the semicircle. So if you substitute the value, it will be pi by 2 multiplied with 25 square. Then by simplification, we will get the value of A2, that is 982 mm square. Okay. Then x2. Here, this point is on the reference axis for the x bar calculation, and the x bar formula for the center of gravity from the base, that means the center of gravity will be possibly here, that is CG2, it will be here. From the base, this distance, okay, from the base, this distance, that will be 4r by 3 pi. Okay, that is 4r by 3 pi. That is from the base to the center of gravity. Okay, this is the base to the center of gravity, that is 4r by 3 pi. But we need the distance of center of gravity from here to here, that is from the reference axis to the CG. If the CG is here, from the reference axis to the CG, we know from here to here, that is 4r by 3 pi, and from this distance to this distance we need. So we can take from here to here, that is 25. 25 minus this 4r by 3 pi. Okay, this total radius is 25 mm. And we need from the reference axis to the CG. But we know the formula from CG to the base, that is 4r by 3 pi. So this we can get by using the calculation, that is 25 from this point to this point, 25 minus this value 4r by 3 pi. Then we will get x1, the distance from reference axis to the CG of the particular area. That means here semicircle. So 25 minus 4r by 3 pi. So we will get this equal to 14.4 mm. Okay. Then the third one, that is triangle. Okay, that is triangle. For the triangle, we know the area, that is A3, that is of multiplied with BH, of into the base multiplied with the H. Here, the base, that is 25 plus 25, that is 50. H, that is also 50. So 1 by 2 multiplied with 50, that is the base, and height, that is also 50. So if we simplify, we can get 25 multiplied with 50. So the A3 value that equal to 1250 mm square. Then X3. Here, actually, this will be symmetry about the vertical axis. That means this particular triangle alone. So we know that the center of gravity, CG3, that will be possibly here. That means that anywhere on the point. That means from the base we know if it is the larger end, it will be 1 by 3h. From the smaller end or the vertex, it will be 2 by 3h. Okay. From the base, 1 by 3h or h by 3. From the vertex or smaller end, 2 by 3h. Okay. Where h is 50. But whatever that is for y bar calculation or y3 calculation. Here, from the reference axis, here you can see that center of gravity will be anywhere on the point, but that should be on this axis, which separates the triangle into two segments. Okay, symmetrically. So this will be CG3. Okay, from this end 1 by 3h, and it will be on symmetry line. So here you can see this distance 25 plus 50, and from here to this axis, that is 25. So 25 plus 50 plus 25, that is x3. So 25 plus 50 plus 25. So the value of x3 we will get 100 mm. Then y3. We know that the formula from the larger end. This is the larger end here because this will be vertex. This distance is h by 3 or 1 by 3h. Okay. From this distance to the center of gravity. Do you understand? From center of gravity CG3 to the base, this point. That is h by 3. But we need the distance from the reference axis y bar. Here you can see from here to here. That is 50. Here to here, 50. 50 plus this distance, h by 3. So, y3. 50 plus h by 3. Here h also 50. Okay, so we can write this equal to 50 plus the h. 50 divided by 3. So we will get this distance is 66.7 mm. Okay, 66.7 mm. So now A1, X1, Y1, A2, X2, Y2, A3, X3, Y3. Everything we calculated. Okay, actually here I think we didn't calculate the value of Y2. Okay, so that we will calculate here. Here you can see the Y2. Here you can see this semicircle, that is symmetry about this axis. Okay, like the triangle, it is symmetry about this axis. The CG2, that will be on the same symmetrical line. So from the reference axis, this distance, that will be 50 by 2. Okay, that will be 50 by 2. So that is 25 mm. Okay, that is y2 for semicircle. That we forget to solve here. So y2 equal to from here to here. That is 50 by 2. So now x bar and y bar. Here already we have the formulas. So to get the value of x bar and y bar, substitute the value of a1 and x1 in x bar. So that means a1, x1, a2, x2, a3, x3 divided by a1 plus a2 plus a3. Same way, here a1, y1 values on y bar. So we will get x bar and y bar. Okay. First x bar. Okay. The value of a1, that is 5000 multiplied with x1, that is 75, plus a2, the simplification 982 multiplied with x2 14.4, plus A3, that is 1250 multiplied with x3, that is 100. Okay. The whole divided by A1 plus A2 plus A3, that is 5000 plus 982 plus 1250. So if you simplify, you will get the value of x bar that equal to 71.1 mm. Same way, we have to calculate y bar also. Okay, then y bar. Here y bar formula already we had noted here. Substitute the value of a1 y1, a2 y2, a3 y3 divided by a1 plus a2 plus a3 in this formula. So here y bar, a1, we calculated the value, that is 5000 multiplied with y1, that is 25 mm, plus a2, that is 982 multiplied with y2, that is 25 mm, plus a3, that is 1250 multiplied with y3, 66.7. Okay, this is in the numerator. The whole divided by a1 plus a2 plus a3, that is 5000 plus 982 plus 1250. So we will get the value of y bar that equal to 32.2 mm. Okay. So here we got both the values x bar and y bar. Okay. So I hope you all understand. Don't forget to subscribe my YouTube channel Vishwaguru, a problem solver, for more videos like this. Okay. Thank you guys. Thanks for watching.